So 7 minus 3.1 minus 0.5 times 6 times 1 is equal to 20.4 inches to the power 3. So therefore Q, right, is equal to Vy over Izz multiplied by Qz. So this is equal to 25 multiplied by 2 because you have 2 nails, okay, left and right nails. This 2 also over here is also due to left and right nails. Okay, so this is equal to Vy. Izz is the same, 197.7. Now Qz is 20.4. Right, so based from here, Vy is equal to 25 times 2 times 197.7 divided by 20. It's equal to 84.6 pounds, okay, or 485 pounds, right? So the lower one's control. So the V allowable is equal to 317 pounds. Okay. So what you learn for this case is to construct the shear flow. Okay. You have to analyze the top and the bottom for this case at the flange. Is because what I'm going to say is because the joints are not symmetry at the top and at the bottom. Okay. I'm going to look at one last problem. Okay, one last problem. Maybe not the whole thing. Probably will solve it in the tutorial. Okay, probably I'll solve it in the tutorial. But let's look at another example. Example number 5. Okay, and I'm going to introduce you to this term. Okay, so this is again another interesting problem. You say, Eugene, you say every problem interesting. So the beam is made of 4 boards nailed together as shown. The nails can resist each support at a shear force of 100 pounds. Determine their requirement spacing S prime and S. Okay, so this is our S and this is our S prime. Okay, and the beam is subjected to a shear force of 700 pounds. Okay, so we are given that the resistance force. Now this type of beam, we call it I want to introduce you, this term is known as the wide flange. Okay, I want to introduce you this terminology. Okay, so you will get used to it later on, right? So we know that the resistance force per nail is 100 pounds. So we want to find the spacing, and we know that the Vy is coming at 700 pounds. Okay, so if I were to draw our transformation again, X, Y, and this is our Z. Okay, and I'm going to give this term. Okay, usually you have to find it, but I'm just giving it so we can analyze the structure better. It's equal to 337 0.43 inches to the power 4, and y bar is equal to 3.3548 from the top. 48 inches from the top. So again, we have to see where failure will occur. Okay, so I'm going to sketch this out. Okay, one here. Right. Again, this is just a sketch. Right. So there are fasteners here, or they're nailed over here. So we know that the joints is going to be the joint are going to be the weakest link. So this is where it's fail. This is where it's fail. This is where it will fail. Then we will draw the shear flow, right? The Q, the Q, small q, right? So these are the small q. It's controlled by the web, and this is our shear force, Py, right? And then we know that it has to come in this way. And then from here, right? Okay. So failure will occur at, I'll call this joint number 1, joint number 2, and joint number 3. Okay. So for joint number 1, right, the arrow, the shear flow of the arrow on the left hand side has nothing to do with the shear flow on the, they are not connected at all. If you just consider the small web. Yeah, the small web. I call this the minor web. Right? These are the minor web. This center one is the major web. Right? So why I'm saying this, with this, then you are able to calculate the spacing. Okay, so the area that you need to consider, as I say, the left web and the right web, they're not connected, are they? Right, they're independent. So the area we have to consider for the web, right, for the small web is just this area. It can be the left-hand side or the right-hand side, okay? So now I'm just going to look at the area. Okay, so we're going to look at the minor web. Right, so Q is equal to Vy over Izz, right, Qz. Okay, so we have to find Qz first. Okay, so the width of the small one, the width is what, 1 inch. The depth is 3 inches. You can see that it's 3 inch, right? And the y bar is equal to 3.3548 minus by 3 divided by 2. Okay, so this is equal to 3.3548 minus by 1.5. That's 3 times 1, so it's 5.5644. Okay, 5.5644 inches to the power q. Okay, so we know, so the q is equal to what, 100 over S is equal to Vy is 700. This is 5.5644 divided by the second moment of area, which is 337.43. Okay, so your S is equal to 100 times by 337.43 divided by 700 divided by 5.5644 is equal to 8.663 inches. Okay, I calculate again. 100 times by 337.43 divided by 700 by 5.5644 is equal to 8.663. Okay. Okay, so that is a spacing for the horizontal nail. Okay, so we have found our horizontal nail. So the vertical nail, which is your X prime, is over here. Okay, so this is the vertical nail. I'm highlighting in yellow. Okay, so the area that we have to consider now is this entire area now. Okay, we have to consider this entire area now, including the joints. Okay, or including the minor web, right? So now we have to consider the major web now. No, I won't call it the, yeah, I won't call it the major web. I call it the vertical nail spacing. Okay, right? So you have Q, Z. You're gonna have twice Q of the minor web plus Q of the top flange. Right? So Q of the minor web we found. So it's 2 multiplied by 5.5644, right? And then plus the top flange. The width of the top flange is 10. The depth is 1, right? And then the Y bar is 3.3548 minus 1 divided by 2, right? So this will be equal to 2 times by 5.5644 plus by 10 times 1 times by 3.3548 minus 0.5 is equal to 39.6768. You realize that once you calculate the first moment of area, everything is easy. The thing is what first moment of area to calculate. So Q is equal to 700, rule number 1, right? Q and I, V and I are the same. So this is 337.43, right? And then the Q is equal to 39.6768. And this whole thing is equal to 100 divided by S. So from here, S is equal to 100 times by 337.43 divided by 700 divided by 39.6768 is equal to 1.214 or 215 inches spacing. Okay, so this is where I'm going to end today. It's the analysis, okay? The analysis to determine how to calculate the first moment of area. Okay, with that, I'm going to end my lecture here. I'll still be around if you have any questions. Okay, thank you.